joining us tonight. And if you're not familiar with AITP, we've been around since 1950 or so, one of the largest technology associations in the US. So we've been around for quite a while, and this is one of our SIG events, so we love it when you can all come and learn from one another. And tonight we're discussing OT, IT, and IoT in manufacturing. So everything you need to know or always wanted to know about the Internet of Things and manufacturing. So first of all, we have our moderator, Federico Scamarella. Fantastic. Federico is the CTO of MDX. And next up, we have our host, Ron Majumdar. Majumdar from Watson Cloud at IBM. And then next up, we have David Pacheco.
It's okay.
David is Digital Enterprise Industry Director of Digital Industries at Siemens and Digital Transformation. And then we have Michael Radel, sorry. And he is the CEO at Enlyt IO. So welcome, gentlemen. Thank you for presenting tonight. Take it away.
You're welcome.
All right, thanks. I'm going to switch.
So yeah, really excited to be here and to moderate tonight. So again, as mentioned, we're going to discuss how OT, IT, and the IIoT, so Industrial Internet of Things, and manufacturing is really changing the way you want to manage your IT operations relating to digital transformation. Its impact on your critical data security planning and driving new business opportunities, as you read in the flyer. So as mentioned, I'm Federico Scamarella. I'm the CTO at MXD. That's Manufacturing Times Digital. We're a National Manufacturing Innovation Institute. This was started by President Obama back in 2012. We actually were founded in 2014. And really our goal and focus is to help US manufacturers in their digital transformation. So we do that in a number of ways. We actually fund projects around digital transformation, so whether it's cybersecurity, workforce development, or just looking at understanding how technologies can apply to manufacturing. We actually convene stakeholders in events like this, but also larger workshops around topics like 5G and what that means to things like what we're going to talk about today. And then finally, we also host events. And so again, if anyone's interested, you can learn more about MXD on our website. That's mxdusa.org. But again, we're not here to talk about me. I just wanted to give a quick introduction of who I am and really give the panel here a chance to introduce themselves and really get this started. So I'm really honored to be with this group of folks. I actually know Davide, and he'll mention that he's at Siemens and talk about that, working here at MXD. I've met Ron many times and doing some great things. And although I've just met Michael today, we've had some good conversations. So I'm really excited about what we're going to have here today. So what I wanted to do really is for everyone to quickly introduce themselves and really start with one question. And I think a lot of us have this in mind today is, where do I start and how to shape real digital transformation? And with that, I think even just your perspective of what digital transformation means to you and what you're doing and really how that can be started. So why don't you start off, Ron?
Hey, thank you so much. Hope you guys can hear me. So my name is Arunava Majumdar, popularly known as Ron, and I work for IBM Center for Advanced Studies. So Center for Advanced Studies is basically we work with universities and research to try to do research projects all over the world. I lead the center for Chicago and the Midwest and India as well, but my students are all over the world, like Australia as well. So that's what we do, amongst other things, working with clients as well. So Siemens is one of our big clients sitting here. So anyway, so digital transformation to me is a step in the right direction in the data world, right? So we do everything through computers in these days. So there was a time everything used to be monitored manually. We used to look at each and every component and take notes, and then we'll go through the manufacturing process. However, these days everything is monitored with sensors. That is the beginning of digital transformation of any manufacturing chain, supply chain, or anything like that. And then eventually to get all this data together and see how we can enhance these processes and enhance our manufacturing, reduce the cost eventually to any of the manufacturing processes and improve the quality.
That's great. So that's, I think you mentioned a lot of things that I wanted to say too, but that's fine. No, let me have my intro and then some additional perspective. So as Federico was saying, I'm Davide Picciotto. I'm part of a team in Siemens called Digital Enterprise. So Siemens is a very big company, and we have like different hats as a company. So we are a big manufacturer of different things, but we're also software solution providers for the industrial world. So I belong to the digital industries space of Siemens, which is one of the three main operating companies we have. The other two are mobility, as you probably know, and healthcare, and smart infrastructure, like we were for. So this on the digital industry side, I belong to a team. I was one of the founding members of the team back in 2015, which incidentally, it's when we started our collaboration at MXD, DMBII at that time. Where our traditional core focus business of industrial automation has started to merge significantly with the software world. And so you may even say that the whole IT-OT convergence in Siemens started back then. So it's when our customers started to ask us, hey, how can we get closer from a vertical integration point of view, OT and IT, and how can we have instead an horizontal integration left to right of our processes. So my team has always tried to find solutions internally in Siemens as a manufacturer, but also externally to our customers in different industry spaces to close these gaps, to try to make sure that departments work better together and the introduction of new products in the manufacturing world is easier. Then of course IIoT has played an important role, and it's been like in like everybody's like attention. So how do I enable devices in a faster and better way in the manufacturing floor? But that's only one little step of an end-to-end digital transformation. So what is a digital transformation for us? It's a lot of things. Everybody can start in different places, but it's significantly like how to connect processes left to right and top down or bottom up, and make sure that an enterprise is truly digital.
Okay, thank you. Michael.
Thank you. I'm Michael Radel. I actually founded my business in college when I was going to DePaul University here. Back then I was getting on a ladder and doing smart home systems. So I've been in the IoT space for a long time. And it's really brought my business and my team exposure to everything from manufacturing with Life Fitness and doing their internet and fitness platform and building out a lab with them to connect how you manufacture a device in its, in that environment, and how that interacts with the space that it's placed in. And to us, digital transformation is really taking the analog to the digital. So in the development of real estate and construction, it's still a very archaic process. There's still blueprints. Sure, there's some BIM and there's some CAD development, but a lot of the firms now are looking towards this as a tool to use to grow their business, to build more efficient buildings, and that's really what we're focused on, is the digital twin of this space per se.
Yeah, I mean, and that's a great point, because I think sometimes we get lost in these words, right, the buzzwords, and so as an institute we'll have manufacturers come and say, hey, I want to do this, but really we stop and try to ask, well, what is the problem you're trying to solve, right? And how can we leverage technologies in a way to help us solve those problems? So oftentimes what we say is, if you're not really, especially in manufacturing, understanding the principles of, say, Industry 3.0, right, lean and things of that nature that are critical, you're not really going to do much with Industry 4.0. You're just gonna, especially if you don't have a good process, you might make a bad product faster, but it's not gonna help you. And so I think one of the questions I would say is, especially as we're trying to understand this, what are some of the small wins that you can show, like if you had to talk, and maybe Michael, we'll start with you.
Sure.
Just some wins that you can provide to say, hey, if I need to put this out to say management or to my CFO or something, like what are some things that
Sure.
would
So
be a good way to start?
I would really speak about a project that we built in the River North area with Light Fitness, not the gym, the actual equipment manufacturer. They make 80% of the treadmills, I think, on the planet. And we developed a Internet of Fitness program for them. Essentially that when you walked into the gym, that the gym knew who you were and acted accordingly. So every device you got on and worked out, tracked your metrics, and that really impacted their manufacturing because the actual treadmill itself was one SKU, but the smart device or the console put on that was a different SKU. So for us to go in and really look at their databases and see that there's discrepancies, and for the products they had out in the field, how to really get past bad data sets, how to clean those up, how to work with the right people in their actual different API departments to deliver a smart gym per se. And we were able to do that in a lab environment. And they've begun to roll that product out now, a couple years later. But those were some small ones that we found with a big manufacturer that was local here. That was a really exciting project where for you to walk into the gym and the gym knows who you are is that's something different. Another case would be in a smart hotel that we developed down in Miami, the Me Miami, where they were utilizing a lot of actually European products and how those were going to integrate into a US hotel. Right. So we were able to show some integrations there that were some wins for both management on the ownership level and then on the flag level too.
Oh, nice. Yeah, and I think just real quick, Davide, and just if you want to build on it's not, but that data piece is so critical, right? Having good data.
Yes.
So many times we work with people that say that they're digitally enabled, and then you look at their data and you're like, okay. And again, it's not a knock on anyone, but I think it's that defining what data is. So if you want to talk about that, but also I think the wins quickly, because you guys obviously have done a lot, so.
Yes, so no, that's a good point. Like, let's start from the data, because you're right, data is not always organized in a way where you can easily say, hey, I give transparency and visibility. No, even in early times, I'm coming from the MES world, Manufacturing Execution Systems. We did the whole project flawlessly, and then there was like the big hurdle in the end was, okay, what about the reports? Give us like reporting. And at that time it was like before this age of Industry 4.0, but the problem was the same one. We were looking like a universe of data, and suddenly like automation maybe didn't provide the data that we needed in order to give that visibility. So the line was working flawlessly, like orders were sent down from the ERP system and then executed by the automation system. OE was great, overall equipment efficiency, but the reality is when we had to provide that data up, then there was a set of like a multitude of different interfaces to be built again and data to be grabbed. So that's where IoT actually helped a lot, because honestly it takes a lot less time to just drop a device in there and capture it, maybe with low code app development, and create like a dashboard and get visibility fast, instead of having to grab data that maybe it's already there inside the automation, but you have to develop like 10 different interfaces on the shop floor. So to me that's one of the reasons why quick wins, and why out of the whole Industry 4.0 space, which is a lot bigger than just IoT, people have chosen that to start with. The only problem is that it gives you visibility, but it doesn't give the manufacturers the control, the left to right and the top down control of the processes. And that's where like some of our recent wins in the digitalization space have happened. Things like how to introduce new products faster, how to reduce the number of clicks that are needed to just do a little variation in a recipe in order to make sure that the regulations of a specific countries are met for a product which has already been manufactured and developed like years in the past, but that little variation maybe sometimes takes like 2,200 clicks by different stakeholders in an enterprise to finally take that recipe down to the shop floor and being executed in another country. So all these things, like creating digital threads, has been like quite a big win for us in different industries, small, medium businesses to large enterprises. So that's like, I don't have a specific example, there are like many, and there is no magic recipe where to start with. There are like, everybody has its own point. It may be data visibility, it may be, as I said, like the whole product development process. It may be just simply connecting OT with IT in order to have that vertical integration with devices on the shop floor called edge boxes and cloud, and have a full integration that goes bottom up.
Yeah, and I don't know if you want to add to that, or I think we were having a brief conversation about well, data. I mean, you know, obviously quite a bit, but this concept of, especially for small manufacturers, you know, maybe talk a little bit about low code, no code, you know, or open source. Like, what are some of the things that you see that might be helpful for people to at least think about how they can get into this transformation process?
Yeah, absolutely. So data is extremely important. So first of all, we need to have ways of gathering the data and then concentrating the data so we can do some analysis on it, do some matrix and all that stuff. But what's very, very important to me, it has always been, not just for manufacturing, but for any sort of data that we gather, is a standardization of the data.
Yeah.
So if data is not standardized, so one sensor is sending some information which is, say a heat sensor is sending some information which is similar to another heat sensor, which has slightly different formats. You're always transforming the data and all this. So staying with some standards is very, very important.
Yeah.
So you can get into a canonical form, as we call it. So you gather the data into a canonical form, and then you can do analysis on it. So if different fields mean different things to different persons, whether it's a healthcare, whether it's manufacturing, or some other field, it's always chaotic, right? So when I used to work with clients a lot, then one of the major things we were always doing was data transformations, because every single system is different. Even ACP systems are slightly different, so you have to do some transformations between them to be able to interpret what you're trying to do, what matrix you're trying to gather. So that's one thing. And then how you gather the data. So sometimes systems are not reliable enough, which is sending data over. You were talking about the cloud. Yes, so a lot of people, what they're also trying to do is connect directly to the cloud from the sensors. There's some unreliability factor to that, because now you have thousands of these sensors, thousands of these devices connected to the cloud, and then you don't know what's going to happen. You're reliant on someone else's routers, obviously beyond your routers. And then obviously there's a security factor and all that stuff related to that. So what we recommend is what I call the proximity network.
Okay.
So you build something through IoT, but you build the proximity network in your say factory or wherever the data is being produced. You were talking about some home solutions, so it can be a home too, but don't send it directly. Create a proximity network which is basically a concentrator, and then you send the data from there. So both can be IoT infrastructures or something else. But the major important thing is it's basically a pub-sub or some kind of a mechanism which is reliable, and then you're sending the data over to the cloud for processing. So processing on the cloud is obviously much better because you can expand easily.
Right.
So if you have, like, say 20 CPUs, few GPUs on a data center, you have to get more equipment in and so on and so forth. Networking, reliability of those machines, everything expands, right? So that's what the cloud gives us. So you can expand very easily as the demand increases, and then you can do more analysis, add more tools there, and so on and so forth, right? Many of the tools come with SaaS offerings, so that's great. Or you can build your own models and do analysis and things like that.
So maybe just to build on that, if you guys want to jump in, because I think this is interesting, but if I'm a manufacturer, right? How do I can I afford these things? If I can't, what are some pieces that I can do, at least again, to get started, to build out that case or to show some success and maybe grow from there?
Yeah, absolutely. So a point of entry should be as low as possible. So anyone can enter, right? So you mentioned open source. That's where open source comes in.
Yeah.
It's a collaborative effort. It's there's lots of open source out there that we can do. Like I was mentioning, RabbitMQ is one of the things I'm using. It's completely open source. The RabbitMQ also has some services on top of it. You can buy those services, but you can start with at zero cost. So they provide multiple protocols, so point-to-point, as well as MQTT, as well as AMQP, which is a streaming protocol. So you can start at absolutely zero cost and start building. You can build these things also on an open source basis. With what I do, I build everything as open source with universities, academia, and others who are willing to participate. So we have certain things that can be standardized and can be given out for free. And then from that free baseline, you can build on top of it. Open source doesn't mean it always has to be open source.
Yeah.
You can build services on top of it. You can monetize it. You can build value-added services, right? So that's kind of the model I always follow. I think the whole world is getting into this open source, plus building value-added services on top of it. So yes, you can always start at a very low level, at a very base point of entry, and then build from there.
And I think, Davide, I know at least, especially, I know there's some university students, some of the software you guys give out for free to students, right? So
Yes, so two things. Like first, like to students, yes, you're right. So we do have all our software part of an academic bundle. So students of all universities can leverage it and use and get started with CAD, with manufacturing software, with digital twin, no matter what, right? So that's available, and it's not only us, like most of the companies have this program. So many people don't know that, but so if you're interested, knock on the door of your university and make it happen, knock on our door and we can make it happen. So another aspect, you mentioned something that kind of like the as a service aspect for small medium businesses, it's extremely important. So we are trying to move all our software and automation software as well ecosystem to like be used as a service, essentially like everything as a service. And why is this important? Because you don't need to, from a CapEx point of view, as an SME, you don't need to make a big investment in a digital twin product for a new machine or a new line or a new plant. You can leverage digital twin in the cloud and use that as a service. And now I'm just giving examples of what I'm most familiar with, but this tendency, this trend of moving to per utilization basis is extremely important in the manufacturing world. So it's getting like, and in fact, what I've seen happening in the past 10 years, it's truly like the manufacturing world learning from the consumer's world. And so what we see is now kind of going hand in hand. Like all the cloud subscriptions that we have as consumers, they're going in the direction of the manufacturing world and they're working well. And so when I gave before the example of the 2,200 clicks to launch a new product, that company has looked at us and has said, hey, can I have as a service subscription so that I can try it I can transform my recipes for like a set of products first before committing to a long-term CapEx engagement. And that actually works. So they transform a few recipes for a few different products, they validated it, and then they moved on. But this as a service concept, moving from CapEx to OpEx, is helping a lot small medium businesses.
And Michael, I saw you shaking your head as a small company yourself, right? This has been a boom for you.
Yeah, and I would really reiterate what both of them said, is that look to open source, look to your existing IT department. There's one or two people that'll take this and run with it. And then utilize your existing IT infrastructure. I think that's something that you can plug into, or you can have, as you said, those networks work within your existing structure to really begin to digitally transform your business. So that's all I would add.
Yeah, and maybe on that, because you mentioned a little bit, I would say just a little bit more talk about IoT and its role in this space, and really what are the most common things in the industry today? Like you've talked about a few examples, but really, is it a lot of homegrown? Is it, you know, stuff, maybe Siemens stuff, or is it kind of a mix? What do you
I would say that it's a mix. In my space, more in the real estate development space, on a new construction project, you can really specify a roadmap and implement that. It's a lot easier versus going into an existing building, trying to upgrade legacy systems that you have to work with. So it's something that I think really needs to be developed more from a top level down initiative, and that there's usually some CapEx issues. I mean, that's really some of the problems that we come into, is that if you want to get into a full digital twin and an IoT environment, that there's some cost prohibitive things to build these custom pieces of software for a large building. And to your point, that if you can offer it as a service, it's much more digestible, it's scalable for everyone.
Okay, thanks. You know,
The point of entry is definitely lowered by
Yes.
that, right?
Yes.
So yeah, if you have to create your own infrastructure before you can, and the expertise, right? So
Yes,
just getting the software and the hardware doesn't solve your problem. You need the expertise to actually build it, right? So that's, yeah.
just real quick, Danny, because you were saying something that made me think about. So if I'm in IT, why should I care about OT? And just maybe explain to us what that is. And you talked about the convergence. I think is an important
I give
topic.
you an example here. So one of the largest brewers in the world, we had helped them solve a big traceability problem, which it took them like many hours to solve, like 72 hours in a war room between people looking at different systems, warehouse, ERP, manufacturing floor, automation equipment, and finally solving it. Like with an enhanced traceability solution, and I'm sure like Ron will like leveraging blockchain traceability, the whole like search mechanism is incredibly faster. It ties all these different systems together in a unified chain in the cloud, in a distributed actually one in the blockchain. But what's interesting is that once we proved it, to make it all work, it required running a store procedure by IT, and we worked on that, on solving the traceability issue on the plant floor with the VP of manufacturing, and we were like all on board. And then we were suddenly stuck for like 6 months because that store procedure was not run by anyone. So that's where IT suddenly is looking at OT and saying, hey, what's going on? And why do you need me? And the others, why do I need you to solve my problem? So that's like happening more and more often now. And so that's where we call the convergence between OT and AT, which is not only like technological, but it's also cultural. And so there are a set of things that can be, it's a change management that need to be put into place, and you're right in saying look at your IT first, because some things are already in place and people don't even know about. So yes, I think we'll all be challenged more and more to create a closer connection between the two worlds, and things like open source software, low code, no code, the edge layer, the cloud layer, and everything in between, they bring us closer. And there are a set of implications that maybe we don't have time to touch today, like security of the data, and how cyber security plays a role in that, because then obviously the more data is being exchanged, the more risk to attack is being created.
No, absolutely, that's a great point. I actually wanted to ask you, Ron, because you sort of touched on it, but especially given your background, we hear a lot about artificial intelligence today, right, AI. Can you tell us some use cases maybe around IoT or other things that you see where AI is fitting into this, particularly as we talk about transformation?
Absolutely. So AI is actually very key to solving a lot of problems, right? But if you think about AI these days, you're thinking about like 3-4 areas actually. So one is in the vision area, computer vision. So what can we do with the computer vision area? The second is NLP. So which is speech, which is language, which is ChatGPT, which is quite famous these days.
Yeah.
So there, that's the NLP, natural language processing area, and then you have the predictive analytics area. So like weather channels and things like that. We always had different kinds of models. I work with, actually I did a huge transformation of the National Weather Service, a data center. This is some time back, they're still using it, fortunately, and sending data. And so National Weather Service is actually a huge router, and then NCEP does all the predictive models. So that's a huge area, which requires a lot of computational power. So that's a, I mean, the bigger the models are, even some of the NLP models, they can be very, very big, and some of the Google models that has been published and things like that. And it requires a lot of GPU power, and which is not really at an entry level, right? It costs a lot of money, but at least we are getting hands on some of these technologies, right? Through services, through some services like ChatGPT or some of the free things that are out there. And many of these models are actually published as open source. So one of the big things that I'm actually looking at now is transformational models.
Okay.
And you can see if you go to Hugging Face, they have a bunch of transformational models and things like that, which are free. Anyone can use it, right? If you know a little bit of Python coding, you can start working on these models. So that's where things are moving. Now, how to run it? Again, if you can start by running it on your PC with a simple CPU. Certain models will not run without specifically NVIDIA GPUs, because you have the Cora libraries and things which are specific to NVIDIA, which is at the forefront of the hardware of GPUs. And there's also TPUs and stuff, but that's kind of a little bit unknown how much of an advantage you're getting out of GPUs, but GPUs, yes. The future of this, we're also looking at how quantum can help. Yes. So there's quantum machine learning. So I did a hackathon last year with University of Chicago and UIUC. We're at the infancy of this technology, okay? So what we did in that hackathon was basically the petal and sepal separation, the iris data set. Can we do that through computer, through quantum, rather than through classical means? So we're at a very, very infant level of this transformation. Each of these algorithms actually needs to be transformed into quantum mechanical language, right? Which at the end of the day is solving a Harmatian Schrodinger's equation, right? So there's a IBM Qiskit, if you heard of it.
Oh,
yeah. QIS, Qiskit. It's open source, it's free, it's like writing quantum with Python, right? So if you know Python, you should be able to start off. It's not exactly like writing classical. It's different, right? Let's not get into too far into that. But it's different. But you can still write it, and it gets translated. And you can run it on a CPU on your laptop to begin with, right? So that's a simulator, obviously. Sure. And then, but the point of entry is lower. Yeah. So you can start off absolutely free, and then you build on top of it. So that's the whole idea, right? Can we get into all these complex algorithms or things? Can we put our hands on it? That's the most important thing. So if we can get started, then slowly we can go into the cloud. We can use some of the, say, IBM cloud resources or some other cloud resources. Everyone's providing GPUs and services on top of it, right? So if we have Watson, Amazon has SageMaker and so on and so forth, right? So everyone has their own artificial intelligence tool, but let's get started and then slowly build on top of it.
Thanks. I want to bring this back around because I'm sure the audience has some questions. We've said the word a couple of times, but I want to carefully define. We've talked about data, you've talked about artificial intelligence. I think the holy grail, for me, at least as we see the Institute, is how do we leverage digital twins? right? So it means a lot of things defined in many different ways. I think it might be important here just to, maybe Davide start off, and then Michael, I would like to hear your thoughts. First, give us a definition, and then really from the manufacturing standpoint, I know you've touched on it, but just maybe at a simple level, why do we care about this, and why do you think it will transform how we're doing manufacturing?
Sure. So first of all, what is a digital twin?
Yes, I'll start with that.
10 people, probably they answer in 10 different ways, or 100 in 100 different ways. So as a matter of fact, we define digital twin as a comprehensive one, which covers the life cycle of products and the life cycle of a production environment. So a digital twin can be a CAD model of any product that we even have in our hands, like bottles of water that you have in front of you, but it can also be, the digital twin is also the formulation inside the Coca-Cola that William has in front of him right now. So, and the recipe. So that's also part of contributing of a high fidelity comprehensive digital twin of that food and beverage product, for example, or of an engine of an airplane, right? So all the little details. But a digital twin, it's also the simulations that go along with it, still on the product side. So how, when I do heat testing, or any type of simulation, deformation testing, any type of velocity, any type of simulation that I do with that product to make it more and more real and get rid of digital prototypes. So that's one of physical prototypes and move to digital prototypes. So that's on the product side. On the production side, you can have digital twin of a machine, of a line, of a factory, right? So they can scale up in that way. And once you build them as a manufacturer, together with a machine builder or with a line builder, you have a high fidelity representation on how your factory will work. You can launch processes in it, and you can understand in advance what capacity, what throughput, can I introduce a new product and leverage the capabilities provided by the automation equipments on the shop floor. So that's a very powerful aspect which drives topics like virtual commissioning. So can I commission virtually equipments before I even start building my new line? So that's the second aspect. And then the third one is the digital twin of the performances of product and of production assets in the factory floors. So you have a set of equipments, they all provide information. We talked about it earlier. Can I create a digital twin representation of what is happening in my shop floor? So there are so many different digital twins, and let me add, there are many more, because if you look at the building, there is a digital twin of a building where we are in, right? And how do I make them all work together seamlessly? It's a big challenge. And I heard metaverse before, industrial metaverse, for example, and I heard NVIDIA mention it as well. Incidentally, we're just starting a big partnership with Siemens and NVIDIA on the industrial metaverse. So leveraging Omniverse to actually improve the fidelity of our digital twins. And so one of the big benefits of industrial metaverse is kind of creating a layer which brings all together all these different digital twins that I just provided. So high fidelity of product design, high fidelity of machines, high fidelity of line design. And we have all of these in all our different digital twin software. The industrial metaverse creates a layer where it's all brought together in that highest fidelity, graphical fidelity possible. So it's both a concentrator of digital twins as well as a way to have it look as real as possible. So it's not only the graphical aspect, but it's really the digital twin that lays behind it. So the mechanical, electric, automation aspect of any equipment in the shop floor and how products run through it. So I know it's a long answer. It's a very complex topic, but it's scalable too. So there is no instruction, you have to do the whole thing end to end, but digital twins help in different aspects of the daily life of an enterprise and of a manufacturer. No matter if it's a small one or a big one, and really as a service model, it's used by everybody.
Yeah, and I think, Michael, you talked a little bit about it as well.
Yeah, that was brilliant. that was well laid out. I can speak to the real estate or the building aspect of it. Which really comes down to a digital representation of a physical space. So you can do that by scanning a space with LiDAR and photos and a Matterport scan per se. And then in doing so, you can layer on top of that, as he was discussing, various data inputs and outputs, whether it's a lighting control like the Lutron lights we have here, video screen, HVAC control, and empowering building owners, superintendents, to really look at their building in a different way. And in doing so, we think that there's a bunch of data sets that will become really valuable. Obviously, you implement AI, you can do predictive maintenance, predictive, things that can, eventually cost you the bottom line.
Yeah.
So, but that can start just in a 3D model, and then that can turn into a building that you build. You can BIM these things out, and you can make sure that every little facet of every rivet in the building's done properly before you build it. You can measure that, you can make sure that your cost is going to remain the same, that you're going to be on budget by actually building a digital twin, and that comes to a building that you end up finishing.
Yeah, no, excellent point. I think we talked about an important aspect is really understanding what is it that you're trying to accomplish, what's the data available, right, to make that, right, as you say, if I want to do preventive maintenance, or if I want to reduce my energy costs, like what am I looking to do? So catching the right data. I mean, I remember for a project that we were working on for one of our members, it was a fairly large project that was digitally enabled, and they said, no, we've got all the data, but a year and a half later and $2.5 million, fortunately we had it for this project, we built a digital twin, and it was just of the material movement in the process. So it wasn't even all the machines and everything, just where was the material at that time, so that they knew if they were injecting something into their process, they knew, okay, I can get this done, right? Because they're running production, but then they're running tests. And so if you don't have that data, right, it takes a long time. So David, I agree, that was a great summary, but it's not that easy, right? There's a lot to it. But I think we're headed in the right direction with what we've heard. So I want to open it up very quickly to the audience for questions, because I know everyone's been waiting patiently. So please go ahead.
Yeah, Federico, in terms of going in the right direction, you started with a very good question. What's the problem you're trying to solve? Well, my name is Carl Bushman. I'm with a supply chain trade association, and the problem that my members are trying to solve is we don't have enough visibility. What's going on here? Yeah. Now, Davida, am I saying your name? I heard you kind of address that matter of visibility. I did hear you use the word visibility several times here. So my question to the panel as a whole, all four of you, what would you like for me to communicate back to my members that they're not doing right, that you experts say they should be doing?
Well, that's a good point, and I think there are like different elements. We all touch on different ones, but the summary of it will be what you need to go back with. So I think first of all, there are ways to increase, there are easy and straightforward ways to increase transparency and visibility of data. And so they shouldn't be afraid of starting the journey because there are like easy entry points at different levels. And I think Ron in particular, you mentioned like how do you do that just by looking at what's available, at creating like a first step of network of visibility of data in a network. So from a supply chain point of view, of course, it's also like data as well, and that data needs to be organized somehow. And that's always a starting point, because yes, I've talked about many advanced things before, I know that, and I know that, but it needs to start from somewhere. And organizing the data, it's always a good starting point. What we always say is like, start with something that also shows you some result on how the end will be. So like start small, but think big. So meaning like think to the end game where you want to be, because otherwise you're just like there in that like experiment stage without really proving and moving around, right?
Go Ron. Yeah. So I want to add to just that. So first of all, there's always silos, right? So there are different groups in their own silos. Data is one part of the problem, but breaking down these silos and getting human beings to interact with each other is another problem, right? So So once that starts, then we can communicate what sort of data each of the teams really want, and then we can see, okay, this makes sense. Let's take this data, that data, and the third data. Let's do a pilot, right, with 3 different types of data, and then see if we can integrate that. What does it reveal? Today, if I say, okay, I don't have any automation in my factory or whatever, I want to have sensors for each and everything, and I want to gather all this data. Well, that's going to cost a lot to begin with, and it's going to be very complex, right? So take a small project with 2 or 3 different types of things. Let's bring everything together. Also break down the silos a little bit. Let people talk to each other. What is really important for the supply chain, and then let's build on top of it. Because if we start in a massive scale, it's going to be very complex. It's going to be 2 years worth of projects, and then we don't know whether it's going to be successful or not, right? So build slowly, do a POC, do another POC, and then build from there.
I think Ron's 100% right that you have to start small. You have to do some proof of concepts. You really have to work with your clients to utilize their existing networks, break those silos down like he was talking about, and you can find wins there, and then you can build on those. And that's really what I think I'd go back to him and say is it isn't a really complex project. You can start small, and you can scale from there to get a lot more visibility into their overall supply chain management like you're talking about. That's logistical, correct? Which, those are other silos that you're talking about. Sometimes those are closed off, sometimes they're open. And that's I'm assuming tracking products from all over the world and when they're going to get here, what port they're in, what trailer they're going to be on, and then when they get to the Prologic warehouse, do you know that it arrived on time? How many pieces are in there? And those are all things that can get quite complex, but if you start small, you can really begin to scale those out and do it on a more cost-effective basis.
Yeah, I would just add, through COVID, we actually were funded through the CARES Act and brought together some solution providers that had different systems on, looking and tracking data. And so what we actually did was, using Software AG, they have a web methods platform, we had all these different solution providers put it together, and it gave these manufacturers who were piloting end-to-end visibility and also using AI analytics, some capability, like if there's a weather disruption, how does that impact my... But the biggest problem is that fear of releasing data for what is going to happen to me. So my takeaway has been, if you're going to do something in visibility, it should go both ways, right? So not that I'm going to use this information to, reduce my cost, but rather I'm going to help you and tell you, like, if I'm ordering 3,000 parts from you, but I have a delay on my end, I'm going to let you know. So if you need to change your schedule or do something to offset and make sure you're not expending costs when you don't need to, that you get that information too. So I think it's just thinking about it differently, like how are we approaching this? Because we're all in the same problem together, and I think we have to get over this, like hiding the data and information and really getting to what's that next level and providing that flexibility. So great question.
Great answers, thank you.
Sure.
On that topic of projects, my question is about project management methodology. 2 assumptions that all of you are executing some combination of waterfall, traditional, agile, hybrid, or managed chaos. My other assumption is that your methodology is not static, it is evolving. And my other assumption is it matters because it's a competitive advantage or a competitive disadvantage. So if you disagree with any of those, I'd love a response. But if you agree with those assumptions, then my 2 questions are, what are the limitations of your current methodology, and what do you want next? 5 years from now, what do you need, what do you demand out of your project management methodology?
I would say budget on what's the cap is what someone's willing to spend on a digital twin, on a true digital twin of manufacturing or a building. Where I see it going, I really believe that these digital twins will transform our overall way that we live and work, because you'll become so more efficient. You'll be able to forecast or see problems before they happen, before they're implemented in the field per se. And they'll become more data-rich environments that you can make better decisions on. The operating of a building will come down, things will become much more efficient. You layer in AI and it just gets very efficient. So I hope that the idea of a digital twin is really a thing that comes to fruition, because it's almost something like out of a movie, right? Like you see Mission Impossible 3, right? And they're like, well, where is he in the building? And it shows his exact location. And he dials into the HVAC system and he, is able to jump around. That's obviously a movie, but for a superintendent to be able to look at a mechanical closet on the 3rd floor or the 13th floor virtually on his phone, get a real data feed, be able to know what part to order or it orders it for you, I think is a real different way to look at how you manage, the actual physical spaces that we interact with every day. Hope that helps.
I would add to that these digital transformation projects, let's go back to digital transformation.
Yeah.
Actually, even more than just digital twin, because digital transformation is digital twin with a lot of other things too. So they're very complex projects that go across disciplines, and maybe what I'm saying resonates differently to whoever is hearing it, but these different disciplines are truly massive projects per se. So there is the building side of the things, there is the digital twin and simulation of the equipment, there is the management of maybe the machine builders and the suppliers, there is the R&D and marketing and quality departments that need to be launching products maybe in this new facility, in this greenfield. And so all of these needs to be coordinated, and all of these, you're right, it's a mix of different project management methodologies. Maybe Agile is probably the best average between all of the ones that you said, but the reality is it's a moving target sometimes, and it's a moving target for all the different work streams, which are completely different and in theory disconnected one from each other in the past, and they suddenly need to be connected because these are the departments that we are tearing down the walls from, and they're suddenly all working together, because otherwise it's not a true digital transformation. Pilots, as they're completely, I think I've suddenly started talking about the different topics. We discussed about pilots, how to start small and scale fast, but sometimes it's not only about pilots, sometimes it is about a full-blown digital transformation. Yeah. And maybe there are fewer companies doing that, but no matter if they're startups, hard-tech startups, or if they're big enterprises, these are the things that they need to deal with at different magnitude levels, but they're completely different streams that suddenly need to work together, and that's complex. And so what I'm saying is that you're right, it's evolving, it's something new that maybe doesn't even exist today in terms of project management methodology. If this makes sense.
Yeah. Well, one thing for sure, there's always going to be changes, right? So whatever we plan, whatever I planned at least, say I'll have a plan for 6 months, maybe it'll stay constant for 6 months. If I plan for a year or 2 years, I'll do this and that. Definitely, a lot of things are going to change, and in IT, software changes a lot, right? So people take different directions. So what I realized is the more abstractions you can make, the better off you are. So if you can abstract anything in the process, right? No matter what the technology changes or some other human-related changes happen or some catastrophe takes place, if you have abstracted what you're doing, it's easier to work with, right? So say I'll give you a very technical solution to certain things, right? So say I'm working with blockchain, for instance, right? So I'm tied into this blockchain technology. I've invested everything into blockchain technology, and then the market goes away and doesn't really work with this blockchain technology anymore. So what do? Now you have to do this huge transformation again, and another year of work or 2 years of work and all this stuff, right? And then with blockchain, it's even more difficult because now whatever has been committed is committed into blockchain. You cannot just retrieve it, and it's a whole different problem. Okay, so now, what if you step back a little bit? Okay? I'm not going to rely on anything in this world. Anything can change. Let's abstract this, right? So what do I want is sort of a, we have consensus issues and all types of things. Let's step back and see any type of technology for blockchain can work for me, okay? So this is a very similar approach we're taking to manufacturing project we're doing with University of South Carolina. Dr. Noble, we're working with him very closely to see how things can be abstracted out, right? So there are processes, let's see if we can abstract out processes, right? So it doesn't matter how it's implemented, who are the people, if we can look at it from an abstract level, we can transform to something else. So we are capturing patterns of different things, right? And then tying these patterns together and see as much as standardization as possible, right? So certain standards are out there, universal architectures and things like that, but certain standardizations are not there. So we know it's going to change eventually, right? But we can look at different layers, right? So talk about inheritance, right? So we look at the base class and inherit to something more specific, for everything, right? And talk about digital twins, right? So we look at it from a hierarchical perspective as well. So you have a component, right? So it can be a small component that you want to actually digitize. So first is the CAD models and all that stuff. Then you need data to simulate and all that stuff, right? But it's a small component of a larger asset. So the next level is your asset level, where all these components come in. Then you have the third level, where your processes and all the workings of these assets together can be automated and done. And then you're talking about facilities. Now the whole factory. Now what about intercommunication and relationships between multiple factories, right? Can that be done? Getting into a metaverse sort of massive scale, right? But nothing is simple, it's very complex. So we have to start with something which is absolutely needed. What do you want to simulate first, right? So that would be the question, right? Talk about NVIDIA, they have a very good simulator, Isaac Sim. A lot of people, I was looking into it, complex, but it's a pretty good environment. Yes, and they also have a Omniverse and all that stuff, right? From NVIDIA. That's a great environment to work with, but I mean, nothing is simple, but again, start small and we grow it, right?
I'll just add very quickly, I do agree with you, but I think somewhere in that question, or at least I wanted to interpret that we fundamentally have to change the way we are teaching our children. And I mean children, like I have an 8-year-old and a 9-year-old, of how they view what, not just manufacturing is, but the importance of creating product or creating something, right, and creating that space. And so for me, it's about understanding how we define what pathways are available to someone and how those digital tools can enable them to think of ways that maybe have never been possible before. So talking about access to data of things that, again, we couldn't have done without these tools. So creatively thinking how one can leverage that in a way that's going to be effective. And, you know, we just don't do that well here, and I think that's something we need to do more of, and I know we've had conversations with other individuals. I just wanted to throw that in just to say that it's, to me, a critical aspect.
There's so much information out there.
Yeah. We're at time. Okay. Well, thank you so much. I think these guys have earned a slice of pizza at least, right?
Yeah.
Let's give them a